Here is some work on area as probability that really combines several different areas of math. And the more we get into this, you really start to understand that it's all connected. We're going to need our geometry to do the area. We're going to need to do some division to figure out our area of shaded divided by the total area. And that leads to probability, which would get us a decimal or a fraction of a chance that my point will land in this shaded circular region. So let's just work it through step by step. First of all, I know that the probability means my chance of landing in this shaded region compared to my chance of landing in the entire total region. So I've got a pretty good chance of landing in that shaded region here. I have an area, a total area of a square that's 4 by 4. So on my computations, my total is going to be 4 times 4 for 16 square inches. And the area of my circle is pi times the radius squared, formula, pi times radius for the area of a circle. And so, moving aside my little block here, I've got my radius 2 times pi, 3.14. I've already done the calculations for this, and it's 12 and 56 hundredths inches squared. We know that this fraction bar means divided by, so I've got this out of this chance. So take your calculators and divide 12 and 56 hundredths divided by 16 and see what you get. My final answer for that came out to 785 hundredths. And I've been told to round my answer to the nearest hundredth. So the nearest hundredth would be right here, 0.78, 0.79. So approximately a 79% chance of landing in there. Alex wants you to write it as the decimal. So I have a 79 hundredths chance of landing in the circle. Let's look at another example. In this problem, the dart hits a circular dartboard at a random point. What's my probability that the dart will land in this little square right here? Now, just looking at my two situations, I had a much greater chance of hitting the circle than I have of hitting that little square. So I know reasonably this should be a smaller chance of landing, smaller probability of landing in the square. So first I'm going to do my total area, which is the area of the circle. Pi times radius, 3.14 times 14 times 14. 614 and 44 hundredths inches squared. And I'm looking for my area of the shaded region, which happens to be a square that's 6 by 6. So I've got a 36 out of 614 and 44 hundredths chance. Put that into the calculator. And I got 0.058589994, ... So, rounding it to the nearest hundredth, I have about a 6%, 6 hundredths chance of landing in that little square. That makes it kind of tough to throw a dart and land there. That's why the bullseye is so tough to hit. But rounded to the nearest hundredths, 6 hundredths, which is a 6% chance of it happening. I hope this helps you with area and probability.